So I got a max temp error. This happens when there is a short circuit. But first, let's see how I ended up in this situation. The problem started when I was printing the harmonic drive. It was a longer print, around 9 to 12 hours. And just an hour before it was supposed to complete, the electricity went off. Though it came back after 10 to 15 minutes, but it was late night and I was tired. So I turned off the printer and went to sleep. In the morning, I resumed the print, but there was no filament coming out. The extruder was clunking. I tried cleaning the nozzle and the printer worked fine for a few minutes, but it got clogged again. So I ordered the spares and the UPS. Now, what happens is that when a print ends, the extruder retracts the filament so that as the nozzle cools, it doesn't fuse the filament inside it. But since my printer got shut off mid print, it didn't have the chance to retract. So that's why it got fully clogged. Also, the stock heat break takes the Teflon tube all the way through, further creating the conditions for clogging. So first I'm going to replace the Teflon tube with this Capricorn tube, which is a bit more smoother and precise along with higher temperature resistance. I'll use this wire cutter for a straight cut. Then in the earlier videos, I mentioned the bed is a bit bouncy, and especially when the print is complete and when I try to remove the clips, the knob rotates very easily even with a gentle touch. So I'll replace them with better quality springs and smaller knobs to avoid accidentally misaligning the bed. Then comes the most important part, the bimetal heat break. The Borden tube ends just at the very top of this heat break, and there is a small hole following that to allow just the filament to pass through. Let's start with the easy part, replacing the bed springs. The end with the wire is a bit tricky, but I'll just fast forward this step. Now let's open the hot end. I'll first raise the temperature to 200 degrees Celsius. Ideally, you should turn off the printer after that and finish the job while the nozzle is hot, but I don't know why I kept it on. There's a real risk of getting an electricity shock, so don't do what I did. It was a mistake. So I unscrewed the pneumatic coupler. Actually, I didn't need to, but the stock version I received has a bit of a defect and it's really hard to get the Borden tube out. So after replacing the Teflon with Capricorn, I opened the rest of the hot end. I tried unscrewing the nozzle, but it was stuck. So I thought, let me first remove the heat sink. And then I tried really hard, but neither the stock heat break was moving nor the nozzle. I even raised the temperature to 250 degrees Celsius. Also got myself a burn. So you have to be really careful when using it. It is really hot temperature and especially the high voltage current. So be safe. I then used all my strength, but it actually snapped the nozzle in two pieces, with the thread still stuck inside the heat block. Now I also need a new heat block. So here's the new one, and since the thermistor and the cartridge came out safely from the old heat block, let's just install this quickly. The cartridge is pretty easy and straightforward. You just have to tighten one screw at the bottom. Now comes the thermistor. Can you see the mistake I'm doing? I'm putting both the thermistor and the screw in the same hole. And as expected, obviously, I ended up with a broken thermistor. I now need to make a cut in this wire and solder a new thermistor to it. But guess what? I repeated the same mistake thrice. So the biggest hole on the left is for the cartridge. The one at the bottom is for the thermistor and the screw we already know. The slightly bigger one at the top is probably for the glass thermistor variety, not relevant to us right now. The screw holds the wire of the thermistor gently so that the thermistor doesn't move. Now let's go ahead and install it. Make sure you don't tight the screw too much because it'll break the insulation. To get a good angle, I have pre-installed it within the heat block first before actually soldering it to the wire that goes to the motherboard, so it gives a good grip to install it. Also, while installing the heatsink, make sure the heatsink is properly aligned with the printer, and you just need to make 5 turns. Don't go all the way because you also need to add the nozzle from below. For some reason, there's no partition between them. Now, let's cut the zip tie and the black sleeve and measure the length of the wire you need. It's better to have a hanging wire than ending up being short. Make sure while doing all of this, your printer is off, and not just the switch on the power module, but also disconnect the plug that connects to the main supply. This is real current we are dealing with. Also, never turn on the printer and especially never heat it up without both the cartridge and the thermistor inside the metal block, because otherwise the printer may never know the temperature and it may keep heating the cartridge, which can lead to fire accidents. You need to be very careful. If you are a minor, make sure you do all of this under parental supervision. Please be safe, it is very important. So coming back, I faced one problem while attaching the heatsink to the metal block. The machining on the heat block might not have been done properly. The block holes don't align well with those of the heatsink, and I really struggled to screw both of them together. It shouldn't be the case. So make sure you buy spare parts only from a credible source, and best if you can get them directly from the manufacturer. Now let's close everything up, and now comes the moment of truth. I probably know why Max Temp Error came. I suspect the thermistor wires must be in contact with the metal heat block because I didn't push the thermistor inside, I just placed it at the very edge. So, most likely, that's the issue. As you can see on the multimeter, the resistance is near zero, so hence proved the short circuit. Now, don't confuse this error with a min temp error, which comes when there is an open circuit, may happen when the thermistor is fused. After removing the thermistor, I checked it with the multimeter, which was for some reason on the wrong setting. I didn't realize it, and it gave me a 0L reading. Actually, the thermistor resistance is about 100 kilo ohms, so we need to point the multimeter to the 200K option. I didn't realize it then and went on to order another spare thermistor thinking this one's fused. So here I am soldering the new one, and yes, I need to put in a lot of soldering practice, but it did the job. This time I checked at each stage if there's still max temp error before soldering, before taping the joints, before screwing the hot end to the printer. It was safe. Let's close it up. No, it's back. It was just a tiny metal flake on top of the thermistor inside the metal block. And I'm not sure, but most probably that was the reason, and it should work fine now. Let's turn off the motors and take the temperature all the way to 200 degrees Celsius, and then bring it back to room temperature and see if it works well. It should. I wish it's taken too long. Let's also do auto home. Oh, that was scary. So as you can see, before the Z-axis hit the Z-axis switch, the nozzle hits the bed, it's probably because I changed the springs. They have raised the level of the bed. We need to move the z-axis switch a bit higher. Let's do that, but don't stress the wire, it can break. Raising it just enough to have some flexibility in the wire, and simultaneously now the switch is above the bed. Phew. One more thing, I need to do PID auto tune. I haven't yet checked what exactly it is, but it seems the motherboard comes in sync with the thermistor and the cartridge. When I took the printer to 200 degrees Celsius earlier, the temperature wasn't stable. It was wobbling between 195 and 204. It's like you heat up the hot end and then turn off the heat, but then it cools down and you need to heat it back up. So this PID auto tune fixes that, and now since it's complete, the deviation is now between 199 and 201. Finally, the printer is working. It took a long time. See you soon.